facilitated diffusion is a particular type of passive transport once again, so it still doesn't use any energy, where we're taking a substance, and in this case it's a hydrophilic substance, moving down its concentration gradient to cross the plasma membrane. So let's set up our plasma membrane once again. Plasma membrane, and the principles are almost exactly the same as simple diffusion. So we've still got the substance going from where it's in a high concentration down its concentration gradient to an area of lower concentration across the plasma membrane, but this time we're talking about the transport of hydrophilic substances opposed to lipophilic substances. Hydrophilic substances have an affinity to water, but they're sort of like a phobia to a lipid environment. And remember, this whole plasma membrane is a lipid environment. So unlike simple diffusion, where lipophilic molecules can dissolve and cross the membrane, hydrophilic substances cannot do that. So for them to go down their concentration gradient, we need to provide them with a polar environment that they can actually travel through. And we do that in the form of transport proteins. So we might have channel protein, and as you guys would also be aware, in our plasma membrane, oh, don't know what I was doing there. Let's get rid of that. Not letting me rub it out, let's just draw it through here. We also have some other integral proteins that are called carrier. And what these proteins do, these transport proteins, so they're integral and transmembrane proteins, so they go from one side of the plasma membrane to the other. They provide this little environment in here which is suitable for a hydrophilic substance to move through. So the channel protein allows things to move in and out freely, still going down their concentration gradient. The carrier protein is one where it sort of accepts the molecule, undergoes a change in shape, and then spits the molecule out the other side.